Good morning. Today is March 19th, 2020. This is Function Focused Home Learning Lesson 2. Today's objective is hopefully by the end of this lesson, students will be able to graph linear inequalities in two variables in standard form from a word problem. So really today we're going to focus on creating linear equations in standard form from a word problem and also graphing and answering questions. Activity number 1, guided notes with examples, which is in your email. And activity 2 is individual practice, aka homework, which is also in your email. Now, I will always send all of the documents necessary in the email. Please do complete the notes along with me while you're watching the video. And for your individual practice, please do your individual practice. This is definitely going to help you be able to see how much you know about these skills and completing these skills. Also, it'll give you a chance to see what you do and do not understand. And then you can always email me or comment on the YouTube channel. So when you're reading a word problem that involves inequalities, you're going to have certain phrases in the word problem that are going to tell you which inequality symbol you need to use. So for example, the phrase at least. For example, you need at least 70 points on the next test to raise your grade. So at least 70 points. And you think about the word at least, that means you have at the lowest amount you can have is 70 points. That means that the amount you have to have has to be greater than or equal to 70 points. You can have 70 points, but you have to have more, that or more, in order to raise your grade. So your number would be 70, and your inequality would be greater than or equal to. Okay. Now remember, when you're trying to decipher which inequality this is, whatever part, think about it as a mouth, whatever part is open is bigger, that's the greater than symbol. Okay, so we're saying that it must be that whatever your score is, let's call your score X, must be greater than or equal to 70. It can be 70, but it must also be more. Next one, more than. I think that's a little bit easier. I will give you detention if you are late more than twice. More than just means greater than. Okay? So the number would be 2 because she said twice, or whoever said twice. And then it has to be greater than 2. She said more than 2. So that means that we're dealing with a greater than. So if X represents the number of times you're late, then X has to be greater than 2. Next up, no more than. No more than. So no more than means that it cannot be more than. Okay? It cannot be more than. It can be whatever that amount is, but it cannot be more than that. Example, I can eat no more than 1,200 calories on this diet. Can I eat 1,200 calories? Yes, I can. Can I eat more than 1,200 calories? No, I cannot. So the number is 1,200, and I can't eat more than that. So that's the smallest number. That's the largest number I can eat. Everything else has to be less than that. So it has to be less than or equal to 1,200. Again, I can eat 1,200, but I can't eat more than that. So everything else has to be less than that. So if X represents calories, the calories must be less than or equal to 1,200. Okay, fewer than, less than. Fewer than, less than. Okay, so this would be kind of a comma. So less than or fewer than is the same thing. Okay, it's two phrases that mean the same thing. If you have less than $50, you can't afford the concert tickets. If you have less than $50, meaning if you have anything less than 50, you can't go to the concert. Can you have $50? Yes, you can have $50. But if you have anything less than, you cannot go to the concert. So if this represents the money you need to go to the concert, then if it's less than or equal to next up, fewer than, less than. So fewer than and less than are two phrases that mean the same thing. For example, if you have less than $50, you can't afford the concert tickets. Okay. So here, what they're saying is anything less than 50, so 49, 48, and onward, you cannot go to the concert. So the number is 50, and if you have anything less than 50, you cannot go to the concert. So if this represents the money you need, if X, the money you need is less than $50, then you cannot go to the concert. Last but not least, no fewer than or no less than. These two phrases are also the same. My dog ate my homework no less than 6 times this year. Okay, so the number is 6, no less than. Okay, so that means that 6 was the least amount of times, the smallest amount of times that the dog ate the homework. So that means that it had to be greater than or equal to 6. The times the dog ate the homework had to be greater than or equal to 6 because it's no less than 6. So it can't go less than 6. So the times that the dog ate the homework, represented by X, has to be greater than or equal to 6. Okay. Go over these and look at these again. I know it can be a little difficult, but when you see these phrases, you have to know which inequality to use. Now, writing the equation. So remember, a linear equation in standard form is AX plus BY. And since we're doing an inequality, it's either going to be less than, greater than, less than or equal to, or greater than or equal to. You have a choice. It all depends on the words included in the word problem. So let's do an example. So the first step we have to do is we have to define our variables in words. What do each of these variables mean in our equation, in our inequality? So it says the athletic boosters operate a refreshment stand at all football games. The boosters earn a profit of 25 cents for each soda they sell. So that's some information. So let's underline that. They profit, meaning they earn money for each 25 cents for each soda they sell and 50 cents for each hot dog they sell. Okay. Their goal is to earn a profit of at least $50 by selling sodas and selling hot dogs. So let's define our variables. So we have AX plus BY is either going to be less than or greater than, less than equal to, greater than or equal to C. So we have AX. So first of all, they told us that the sodas, the sodas cost 25 cents. Okay. So we're going to let A be 25 cents. So 0.25. Okay. And if you notice that A and X are together, so A, B, and C usually, when we're talking about this, will quantify as dollars, money. So since A and X go together, we have to make whatever the dollar amount go with the whatever it cost that much. So A was 25 cents and X would be sodas, because the sodas cost 25 cents. And we don't know how many sodas were purchased. So this is going to be number of sodas. Okay, so each soda costs 25 cents. We don't know how many sodas. So X is going to represent the quantity of sodas sold. Okay. Again, now we're going to do that for hot dogs. Hot dogs cost 50 cents, 0.50. We're going to make Y, since B and Y go together. B was 25 cents. Y is going to be the number of hot dogs. And I'm putting a number of the hot dogs, number of sodas, but number of sodas sold, because technically we're selling them. Okay. And we got that all from our word problem. Now C is going to be the total. So if we have the number of hot dogs sold, the number of sodas sold, we want that number to be, we want to earn at least, so it has to be at the smallest amount, it has to be 50. So the number is going to be 50. And since we want to earn at least $50 by selling hot dogs and sodas, we're going to say we want the number of hot dogs and sodas sold to be greater than or equal to 50, because it's at least 50. Okay, we want 50 or more. Okay. All right. So now we're going to write out that inequality. Okay, so let me write that like this. So now we've already defined our variables, and now we need to plug it in. So we set our A. So remember, this is going to be AX plus BY, and then C, whatever your C is. So A was 25 cents for the amount of sodas sold. We don't know what that amount is, so that X stays there. Okay. B was 50 cents for the amount of hot dogs sold. We don't know how many hot dogs were sold, so we just leave it as Y. X and Y represent quantities we do not know yet. And then we said we want it to be greater than or equal to $50. So our C here is $50. Okay. Right. So we create our inequality. 0.25 times X plus 0.5 times Y is greater than or equal to 50. Another way to say this is 25 cents times the number of sodas sold plus 50 cents times the number of hot dogs sold has to be greater than or equal to $50. Okay. Another example. Jessica is doing the chemistry and algebra homework. Each chemistry problem takes her 5 minutes to complete. So each chemistry problem takes her 5 minutes to complete. Usually, if they give you numbers or quantities, then that's useful information to create your inequality. Okay. Each algebra problem takes her 2 minutes to complete. Jessica's favorite TV show is going to be on, so she needs to take less than 90 minutes total to complete her homework. Excuse me. Allergies, people. So what do we know? We know each chemistry problem takes her 5 minutes to complete. Each algebra problem takes her 2 minutes to complete. And she needs to complete her homework in less than 90 minutes so she can watch her favorite show. Sounds like real life, doesn't it? So now let's define our variables in words. Okay. So we're going to say A, and remember it's AX plus BY, and then C. And in here, in this space, goes any inequality, depending on what's the wording. So A is going to represent the amount of time So A is going to represent the amount of time to do chemistry problems. One chemistry problem. So if A is the amount of time to do one chemistry problem, then X must be number of chemistry problems. Okay. And if B, we're going to define as amount of time to do one algebra problem. I just realized, guys, I did not define in words all of the last variables, but I'm doing it now. Okay, so now we're just saying in words what it means. Okay, so if B is the amount of time it takes to do an algebra problem, then Y is going to be the number of algebra problems. If you see here, X and Y are usually numbers we don't know. Okay, so they're amounts we don't know. We don't know how many chemistry or algebra problems there are. Okay, when we start answering questions, then you'll see that they'll give you numbers to plug in. Okay, and then we said that we want it to be less than 90 minutes. So that means we have to have less than 90 minutes. Okay, now we can fill in all these things. So we said A was the amount of time it takes to do a chemistry problem. Well, the problem told us that it took her 5 minutes. So A is going to be 5. B is the amount of time it takes her to do the algebra problem, which was 2 minutes. Okay. All right, and remember, X and Y stay X and Y. We don't know what those numbers are. So it's going to be 5X, because A goes with X, plus 2Y is less than, we want it to be less than 90 minutes. So what we're saying is 5 minutes times the amount of chemistry problems plus 2 minutes times the amount of algebra problems, we want it to be less than 90 minutes. Okay. So what's going to happen is after you have created your inequality, then they ask you to answer questions. Okay, so we're going to do the first step first, which is to create a inequality. So it says Goldilocks is planning a cookout for the 3 bears. She has budgeted a maximum of $60 for hamburgers and hot dogs. So a maximum of $60. This is important. Maximum $60. What does that mean? Maximum $60. That means that $60 is the largest amount that she wants to spend. So that's going to be less than, we want it to be less than or equal to 60. Okay. Hamburgers cost $3 a pound. Hot dogs cost $2 per pound. All this information, make sure you're underlining or highlighting whatever you have access to. Okay. So let's define it. Again, it's AX plus BY, and then the inequality symbol C. Okay. So A, so we know hamburgers cost $3 a pound. Remember, A and B are usually, and C are usually going to be a dollar amount. Excuse me. So let's say A can be hamburger costs $3. So the cost of hamburgers, cost of one hamburger. Okay. And since we know the cost of one hamburger is $3, we're going to make up a pound. cost of a pound, 1 pound of hamburgers, sorry. Then we know X is then going to be number of pounds of hamburgers. Okay. Again, we don't know what X is. We do know that the cost is $3. So B must be the cost of a pound of hot dogs. Cost of a pound of hot dogs. Therefore, Y must be the number of pounds of hot dogs. Okay. So we want the cost of a pound of hamburgers times the pound of hamburgers plus the cost of the pound of hot dogs times the pounds of hot dogs to be less than or equal to $60. Okay. And that should make sense to you. She wants to spend less than $60. Now, in order to write our equation, we're going to say the cost of 1 hamburger, 1 pound of hamburger is $3 times the pounds of hamburgers plus the cost of hot dogs, a pound of hot dogs, 2 times the number of pounds of hot dogs to be less than or equal to $60. Okay, so this is our inequality. All right. Now we have to answer questions using our inequality. I'm going to rewrite it. Okay, now given the information that we know what A, B, C, and X, Y mean in context of the scenario, we have to create an inequality. So we want A to represent the cost of 1 pound of hamburger. So we know 1 pound of hamburger costs $3. So it's going to be 3 times X, which is the number of pounds of hamburgers. We don't know that, so X remains an unknown. They didn't tell us how many pounds of hamburgers. Okay, plus B, which is the cost of the pounds of hot dogs, which we know is $2, times Y, which is the number of pounds of hot dogs, which we do not know. And we want all of that. We want the pounds of hamburgers plus the pounds of hot dogs to be less than or equal to $60. Okay. So we have created our inequality. Now, it asks us, letter B, says, what is the maximum number of pounds of hamburgers she can buy if she buys no hot dogs? Okay, we're only dealing with our unknowns here. They're going to tell us what our unknowns are now, and we have to plug that into our equation. Or, I'm sorry, our inequality. So it says, what is the maximum number of pounds of hamburgers? So we want to know what is the maximum number of pounds of hamburgers. What represents pounds of hamburgers? X. So we want to know what is X if she buys no hot dogs. So if she buys no hot dogs, which is Y, right? Y represents number of pounds of hot dogs. So what is X is the question if Y is 0. No hot dogs means 0. So all we have to do is plug in 0 for Y in our equation. In our inequality. So we have 3X plus 2Y is less than or equal to 60. So now we know Y is 0. So now we have 3X plus 2 times 0 is less than or equal to 60. And we're going to solve. These cancel out. 2 times 0, 0. This becomes 3x. 3x is less than or equal to 60. Divide by 3 on both sides. We get x is less than or equal to 60 divided by 3 is 20. So what's the maximum amount of pounds of hamburgers she can buy if she buys 0 hot dogs? 20 pounds of hamburgers. That's the maximum. That's the answer. If she buys 0 hot dogs, she can buy 20 pounds of hamburgers and still be less than or equal to $60. Okay. All right, next up. The question says, what is the maximum number of pounds of hot dogs she can buy if she buys no hamburgers? So when they ask question, what we're looking for is the maximum pounds of hot dogs, which is Y. We want to know what Y is. If she buys 0 hamburgers, that means that X now is going to equal 0. X now is going to equal 0. So we have our inequality, 3x plus 2y is less than or equal to 60. Here, X is going to equal 0. X represents the pounds of hamburgers. We bought no pounds of hamburgers, therefore it's 0. 3 times 0 plus 2 times y is less than or equal to $60. Well, 3 times 0 is 0, so these two cancel out. And we're left with 2y is less than or equal to 60. Divide by 2 on both sides. Y is going to be less than or equal to 60 divided by 2 is 30. So the answer is the pounds of hot dogs she can buy if she buys 0 hamburgers is 30 pounds of hot dogs. Okay. Now, let's graph it. Let's graph it. So, in order to graph, we have to have a title, labeled axes, numbers, and points. Okay. So, our title here, and I'm going to write it off to the side over here, can be cookout food chart. It can be multiple different names, but let's just name it cookout food chart. So we're going to say that the x-axis, if we look at our equation, we said that x represented the number of hamburgers, the number of hamburgers or pounds of hamburgers bought. So the pounds of hamburgers. Okay. And then we said, because it's the x-axis, and we said that y represented the pounds of hot dogs. So pounds of hot dogs. Okay. Okay. Now we need our numbers. Well, if you didn't realize before, here, when we did this, we basically found our x and y intercept. So here, the pounds of hamburgers, the point would be, since x is 20, it'd be 20 and then 0, because x was 20 pounds, y was 0. And here it would be 0, 30. Okay, because x was 0 and y was 30. Just like we did the day before, in the lesson before, where we found out x and y intercept. So now we have to graph this using some numbers. We have to create our own numbers. So we have to decide what would it be good to count by. What's our scale here? Can we count by 5s? Can we count by 10s? I think we should count by 5s, because if we do This is 0. We do 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. If we do by tens, it'll make the graph too small. So this is going to be 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. And I'm going to make that the same scale on both the X and Y axis. So it's going to be 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. Now, sometimes you might have to count by 2s, by 4s, by 10s. Okay, it all depends on the scenario and what makes sense. So we found that our x-intercept was 20, 0. So I'm going to go to my x-axis and I'm going to put the point 20, 0. Okay. And I'm going to go to my y-axis and I'm going to put the point 0, 30. Okay. Now, we're dealing with an inequality here, so we have to decide whether it's going to be a solid line or a dotted line. This is exactly why I taught you guys that skill in the past couple of classes. So because our inequality here, if you look here, our inequality was 3x plus 2y is less than or equal to 60. That less than or equal to means that it's going to be a solid line. So I want you to take your ruler, always use your ruler, and you're going to connect your two x and y intercepts with a solid line. Now, we need to figure out where to shade. Because remember, inequalities have dotted or solid lines and shading. Where do we shade? Well, we're going to test it. We're going to test the point 0, 0. Again, regardless whether we're doing word problems or whether we're just graphing outright, testing is always useful. Let's test the point 0, 0. So 3x plus 2y less than 60. That's our original inequality. We're going to plug in 0 for x and 0 for y. So it'll be 3 times 0 plus 2 times 0 is less than or equal to 60. Well, 3 times 0 is 0 plus 2 times 0 is 0. So 0 is less than or equal to 60, which is true. So we're going to shade on the side where the point 0, 0 is, which is right here. Okay. All right. Okay. So now it says give 2 more examples of hot dog and hamburger Goldilocks could buy and stay within her budget. Basically, that's saying give me 2 more solutions, and the solutions are always in the shaded area. So the solutions are always in the shaded area. So it can be any 2 that's in the shaded area. For example, I can choose the point 5, 5. Okay, she can buy 5 pounds of hamburgers and 5 pounds of hot dogs. You can do the point 5, 20. She can buy 5 pounds of hamburger and 20 pounds of hot dog. You can do 10, 10. She can also do 15, 5. Which means she buys 15 pounds of hamburger, and 5 pounds of hot dog. Any of these would be correct. Actually, anything in this shaded area would be correct. So people can have different answers and still be correct. Okay. All right. Now for your homework, you're going to be doing the same thing we just did. Okay. You're going to be doing the same thing we just did. So use your notes to complete the homework. You're going to read your word problem. Underline all the important information you need. Define your variables and words. And then create your inequality. again, AX plus BY, put your inequality symbol, depending on the words, C. Now, you're going to find your two intercepts, your X and Y intercepts, which is the same thing we just did. We just did it in a different way. Remember, for your X-intercept, Y is 0. For your Y-intercept, X is 0. Okay, show all of your work. Show all of your work. Then you're going to graph it. Make sure you have a title, that you label your axes, that you have shading, and a dotted or solid line. Okay. I will be posting your next lesson on Monday. I hope everyone is staying happy and healthy, and I'll see you on Monday. Bye.